Hello listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Welcome, my students. I am by name Nathaniel James Yayok, and I'm here once again to take you on a topic: metal joining processes in general metal work. Now, we shall be considering the following outlines. We will define metal joining, types of metal joining processes, arc welding, which is also known as SMAW, the principles of arc welding, basic equipment for arc welding, welding joints, defects in welding, tools and safety wears. Then finally we take assignment. Now, by way of definition, metal joining is a very important aspect of engineering craft practice in terms of manufacturing and production of articles, projects, designs in automobile and the aircraft industry. This process is very, very important, and it's a key factor of joining component parts together. Now, metal joining can be defined as the process which involves bringing two or more separate parts together as one member. Most products are made by assembling a number of component parts together. There are two major joining processes that we have in the industry and manufacturing plant. One, we have the permanent method of joining process, and then we have the temporary method of joining process. Now let's start with the permanent joining process. Why are they permanent joining process? They are permanent joining process just as the name implies. It is a process that is used to join component parts together permanently with the intention or with the view of leaving those same parts to remain there for the time being, but without the nurture of dismantling them in future. So this set of joining methods are subdivided into the following. We have the first one, which is welding, where I want us to talk most on our context today. That's the welding. It comprises of arc welding and gas welding. We have the brazing, we have the soldering, we have the forging, and we have adhesive. These are the 5 main methods that we use to join component parts permanently. And the first one, which is welding and arc welding, is what I want us to discuss later. Let's move to the temporary and semi-permanent method of joining metals together. This set of methods or process that we use to join metals is done in such a way that the metal are brought together with the intention of dismantling them, of losing them later in the near future for the sake of maintenance, for the sake of repairs, and so on. So they are temporary, and sometimes we call them fasteners because they are used to fasten component parts together. This set of process involve bolts and nuts, which is commonly found around. You know, the usual bolts and nut that is used on any machine, on the decks, in our motor vehicles and motorcycles. You find several bolts and nuts in different sizes. They are used to join component metal or component parts together for that purpose. And of course, we have these screws and studs. These studs and screws are also used for fastening parts together temporarily. And of course, we have the pins and clips. In manufacturing and production, you find out that we use this component to join parts together temporarily. Now, there are other semi-permanent that we use. They are not permanent, but are semi-permanent. They can decide to be permanent when they are left for a long period of time to serve a purpose. These semi-permanent are also known as folded joints. Example of this includes the groove seam, the pan down, the knock up, and the rivets. These are a set of fasteners or process of joining metals together that thin sheets of metal are used to fold them into shape and then hammer them with a mallet, and they remain a joint. But later, they can be unfolded and be dismantled as a separate component part. That is why we call them semi-permanent method. Now, let's go to the business of the day, where I want us to discuss about the welding process, which I said is very important in the manufacturing plan. Now, we have what we call the shielded metal arc welding, which is also known as SMAW, the acronym, shielded metal arc welding. Now, the shielded metal arc welding is a process where intense heat of about 5,000 degrees Celsius is produced to join pieces of metal with an electric arc set up between a flux-coated electrode and the workpiece. Now, this shielded metal arc welding operation or method of joining metal cannot be achieved without following a certain principles. Now, like I said, intense heat is generated on the welding machine that is used to carry out this operation. Now, let's see what are the principles of arc welding. The alternating current, which is also known as AC, not the air condition we know at home, but this one is alternating current or a direct current, which is also known as DC. Welding machines supply the necessary heat required for welding, which is obtained through the arc stroke between a coated electrode and the workpiece, which melt together, producing a gaseous shield and slag to prevent atmospheric contamination of molten metal joined or clean, produces a clean bit. Now, we have two basic machines that we use in this operation. Like I said, the AC and the DC, where we are going to see what this AC and DC does in the arc welding operation. Now, there are steps that we consider in carrying out a successful arc welding or shielded metal arc welding. Number one step is striking the arc. And then 2, maintaining a gap of about 1.5 to 3 millimeter between the parent metal and the electrode. There should be a gap. Then the third point, or the third point step is running the bit at an angle of 75 to 85 degrees. Running the bit at an angle of 75 to 85 degrees. Now, the welding equipments. There are basically welding equipments that we use. The main equipment that we use in carrying out a successful arc welding is the AC transformer and the DC or rectifier. They are the main equipment that provide the power sources which produces heat suitable for welding varieties of metals together. Now, look, when you look at the screen, you see a machine. This machine tells you that it's a welding machine because it has cable. 2 cables are rolled or are folded by the right and at the left side. This cable enables the current to flow. Now, we're going to see that the use of the cable later. But for this machine is the AC transformer. That means an electric current comes through this machine in high voltage and is transmitted through these cables to the workpiece. Now, another important equipment that we use to carry out a successful arc welding operation is the electric holder or the electrode holder, which is also known as the tongue. It's a device that is used for holding the electrode and conduct current on it. It has jaws made of copper to grip the bare end of the electrode in any position. It is insulated with heat-resistant material to prevent the heat getting into one's hand. Now, this tool or equipment on the screen is that part of the equipment that is used to hold firmly the electrode. The electrode is held in position by the electrode holder. That is why it's called the electrode holder or the tongue, and it's insulated so that when you are working, you know we are using intense heat, so there is that tendency of the heat transferring to the handle where the operator is holding. So there is that need for insulating the handle for proper operation. The next one we have here is the welding cable and arc. The welding and arc cable. Now, the output cables from the welding power source makes up the welding cables. They are made flexible for easy manipulation of the electrode holder during welding. They are well insulated with durable and hazard resistant rubber. Now, on the screen, you can see a set of cable. And inside of the cable is wires, series of wires, multiples of wires, tiny wires that are insulated. This set of cables are used. One is to be attached to the electrode holder or the tongue, and the other one is to be rolled or attached to the welding machine, and a clamp, which is also known as a return cable or the arc cable. Now, this enables the completion of the arc that is generated at the beginning when an arc is struck on the parent metal. Now, by the striking of the arc on the parent metal, the return cable enables the cycle to be complete, thereby creating that arc that we say earlier on that a gap should be provided between 1.5 to 3 millimeter space or gap, so as to be able to run the bead. The next one is the electrode. Now, this electrode is another important equipment that we use to carry out welding operation in arc. It's a piece of wire or rod of metal or alloy with or without flux covering, which carry current for welding to take place. The flux covering serves three purposes to the weld joint. Now, this electrode, we call it a coated electrode. It's coated because there is a flux that is used to cover the wire. Now, this covering is called the coated. This coating serves so many purposes on the weld bit. And we have the following main purpose of the electrode coated flux. The first one is it maintains an arc stability. It maintains arc stability. That is to say, by the time you strike the electrode on the parent metal, an arc is generated between the gap. Now, this flux enables that arc, the gap between the parent metal and the electrode, to be maintained. That is the function, one important of the arc, the flux. The next one is to protect the metal, the weld, from the atmospheric contamination. There are other contamination that can occur into the molten pool or the bead you are making, or the joint, as the case may be. But this, the presence of the flux enables to shield the bead from any atmospheric contamination. The next one is it produces the oxidizers such as silicon, manganese, which remove harmful oxide from the weld joint. There are foreign materials that can come into the welding joint, thereby rendering the joint weak. So this flux enables it to remove the oxide that demerit the joint. Then we move now to the types of welding joints. Now, there are four basic joints in welding that describe the beads. When you are running a bead on a joint, we have these five basic joints that describe the bead you are running. Number one, we say we have the boot joint. The boot joint is joining metal in the same plate. You have plate A and plate B, just like you have it on the screen. Now, the boot joint is a joint that comes just in between the two parent metal, joining them and running the bead. That is the boot joint. Then the next one is the T joint. The T joint is joining two metal at a right position or at a right angle. You have the first metal, or the parent metal A, is lying flat, and the parent metal B is lying vertically on it, and you have the welding bead roll on two ends. Then the corner joint. The corner joint is similar to the T joint. But in this case, it's done only on one side of the angle. It's done only on the one side of the angle, but it's at the position of T. On the other hand, you make another one which is called T joint. But this one is just made only on a corner. Then the fourth one is lap joint. The lap joint uses for joining overlap plates. A plate that overlap each other, like you can see on the screen. Plate B or parent metal B is overlapping parent metal A, and you have the joint or the bit run at 2H of where the lap end. Now the next one is the H joint, which is the last one. This H is mainly for thin sheet metal. We use this kind of joint on a thin sheet, a material that is less than 0.12 1.3 millimeter in thick. Then we have what we call the welding defects. Welding defects can be seen as the imperfection, discontinuity that occur in the welded part due to improper procedures. So there are a lot of techniques and procedures that we need to undertake in order to carry out a successful welding to avoid this imperfection and discontinuities. Welding defects are generally as a result of poor welding techniques and unsuitable welding consumable or parent metal. Now at times we use series of material. We have the mild steel, we have the cast iron, we have the aluminum, we have coppers and the rest. Now it is the techniques that you apply to a particular kind of material that determine how the joint will look like, to avoid imperfection and the discontinuity that can be found on the welding joint, which will result to defect. The major weld defects include the following. We have major welding defects, about 5 of them. The first one is undercutting. Undercutting is applying excess welding current. Applying excess welding current. When excess welding current is applied to the joint, you are sure of having what we call undercutting. Now the next one is lack of fusion. Lack of fusion is the reverse of undercutting, because if the current is not sufficient enough, then the welding joint will be weak, and that is a defect. The next one is porosity. Porosities are blowholes that are found on the welding joint. This is due to the rusty or a painted surface. You just start welding without cleaning the surface, brushing it with the wire brush before running the bit. Once that happens, there is tendency of having pinholes, that is porosity on the weld. Then the next one is slag inclusion. Now slag inclusion is as a result of the incorrect manipulation of the electrode. Now when you are running the bit, you need to know that that gap of 1.5 to 3 millimeters should be maintained. If not, there is that tendency that the flux will mix with the joint, thereby causing what we call flux inclusion on the welding joint. At the end, the joint will be very weak because of the slag. The last one is cracking. Cracking is a result of a poor welding techniques. If you have a very poor welding techniques, that will tell you how the work will crack. And it also involves overheating the joint. Now that brings about crack because the joint will be so brittle. Now these are the different joint defects that we have discussed: the undercut, the crack, the slag inclusion, the porosity, and the lack of inclusion or fusion. These are the 5 defects we have in welding. Then lastly, we have safety wears and equipment that we need to put on anytime we are carrying out a welding operation. Now, the first one is hand shield or helmet. This is very important because you are dealing with chemical. The electrode burns down as you run the bit, now produces sputters and fumes coming out from the joint. Now this will fly into your air or your body and then creating what we call arc eye because of the intense heat that is generated at the light called ultraviolet ray. So you need the hand shield or the helmet to cover your face. And also we have the dark goggle, which is not the ordinary goggle we use, but the British standard that you can use to see the point in which you are welding. The next one is the hand glove, a leather hand glove, a strong one that you use to cover your hand from the splatters of the welding or the molten metal that can get to your hands. Then of course you have the safety boot, which is very important. You have the overall or apron, which must be a leather apron. Then of course you have the chipping hammer that chips the slack that settles on the bit. And then lastly you have the wire brush to clean the welding joint. Now before I go, I have the following assignment for you to do at home. Number 1A, what is metal joining? What is metal joining? B, differentiate between permanent and temporary metal joining, given 3 examples of each. Number 2, explain 4 SMAW, which is shielded metal arc welding equipment. Explain 4 of them. Number 3A, name 2 importance of flux on an electrode. B, state 4 welding defects and give the causes for the defects. The assignment, number 1A, what is metal joining? What is metal joining? 1B, differentiate between permanent and temporary metal joining, given 3 examples of each. Number 2, explain 4 SMA, which is shielded metal arc welding equipment. 3A, name 2 importance of flux on an electrode. Name 2 importance of flux on an electrode. B, state 4 welding defects and give the causes for the defects. Thank you for listening. My name remains Nathaniel James Yayok. In case of any question or you want to reach me, my number is on the screen, 081 30 86 32 82. Once again, 081 30 86 32 82. Stay home, stay safe. Coronavirus is real. Thank you. Have a nice day.